Anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028. Date: February 4, 2025. Introduction. Recent projections suggest a significant transformation in energy costs across several key sectors in the U.S. economy. By 2028, a 50% reduction in energy costs is anticipated in the transportation, manufacturing, agriculture, and data centers industries. This optimistic forecast stems from advancements in technology, strategic initiatives, and a national push for energy efficiency and sustainability as outlined in a report by the U.S. Department of Energy (DOE). Current energy landscape. As of 2023, data centers account for approximately 4.4% of total U.S. electricity consumption, consuming around 176 terawatt-hours (TWh). With the rise of artificial intelligence (AI) and the growth of domestic manufacturing, this demand is projected to escalate dramatically, potentially reaching between 325 and 580 TWh by 2028. This increase will likely raise data centers' share of total U.S. electricity consumption to between 6.7% and 12%. The DOE's findings reflect a broader trend of increasing electricity demand driven by technological advancements and shifts towards electrification in various industries. The report emphasizes the need for innovative solutions to manage this demand while ensuring affordability and reliability in energy supply. Key strategies and innovations. To mitigate the anticipated surge in energy demand, the DOE is focusing on several strategic initiatives. 1. On-site power generation and storage. Encouraging data centers to adopt on-site energy generation and storage solutions can enhance their flexibility and reduce reliance on the grid. This approach positions data centers as assets for the energy grid rather than burdens. 2. Utilization of retired infrastructure. The DOE aims to repurpose existing infrastructure from retired coal facilities to support new energy needs, particularly for data centers. This strategy not only optimizes resource use but also helps in transitioning to cleaner energy sources. 3. Innovative rate structures. Collaborating with stakeholders to create favorable rate structures will be crucial in maintaining affordability while accommodating the expansion of energy-intensive industries. 4. Advanced technologies. The commercialization of next-generation energy technologies such as geothermal energy, advanced nuclear power, and long-duration storage solutions is essential to meet the growing demands of these sectors while promoting sustainability. Industry-wide impact. The anticipated reduction in energy costs by 2028 is expected to have far-reaching consequences across various industries. Transportation. The shift towards electric vehicles (EVs) is set to revolutionize the transportation sector, leading to lower energy costs. Investments in EV infrastructure and advancements in battery technology are crucial components of this transition. Manufacturing. Increased electrification and the adoption of energy-efficient processes are projected to significantly reduce operational costs. These advancements will enhance competitiveness and foster innovation within the manufacturing sector. Agriculture. The integration of energy-efficient technologies in agricultural practices will lower costs for farmers, promoting sustainable farming methods and improving overall productivity. Data centers. As data centers expand, effective energy management strategies will be paramount. The DOE's initiatives aim to ensure these facilities can meet their energy needs sustainably and affordably. Timeline and future outlook. The following timeline reflects the projected energy consumption changes in data centers and associated industries. 2014, data centers consumed 58 TWh of electricity. 2023, consumption increased to 176 TWh, representing 4.4% of total U.S. electricity usage. 2028, projections indicate consumption may rise to between 325 and 580 TWh, potentially increasing the share to between 6.7% and 12%. This timeline highlights the urgent need for innovation and adaptation across industries to meet rising energy demands while maintaining cost effectiveness.
Conclusion.
In conclusion, the anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 is underpinned by strategic innovations and technological advancements spearheaded by the DOE. The proactive approach to developing clean energy technologies and optimizing existing infrastructure is vital for balancing energy needs with sustainability goals. By leveraging these developments, the U.S. aims to foster economic growth, enhance energy affordability, and transition towards a more sustainable future in an increasingly electrified economy. Sources: 1. U.S. Department of Energy 2024 Report on U.S. Data Center Energy Use. 2. Reuters article on U.S. electric utilities and surging power demand related to data centers. The anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 presents several counterintuitive insights that challenge traditional assumptions about energy consumption and cost dynamics in these industries. Below are key points that reveal these counterintuitive elements. 1. Rising energy consumption amid cost reduction. One of the most striking pieces of counterintuitive information is the simultaneous expectation of increasing energy consumption alongside a 50% reduction in energy costs. Traditionally, one might assume that rising consumption would lead to higher costs. However, the report indicates that advancements in energy efficiency and innovative technologies could offset these rising demands, resulting in lower costs. For example, data centers are projected to consume significantly more energy, rising from 176 TWh in 2023 to an estimated 325 to 580 TWh by 2028, yet the strategic initiatives put forth by the DOE suggest that costs can still be slashed through improved efficiencies and alternative energy sources. 2. Transforming data centers into energy assets. Another counterintuitive aspect is the idea that data centers, often viewed as energy burdens, could become valuable grid assets. The DOE emphasizes strategies like on-site power generation and energy storage, which are aimed at enabling data centers to manage energy demand more effectively. This flips the conventional narrative that data centers are merely consumers of energy. Instead, they are being positioned to contribute positively to the grid, potentially stabilizing energy costs further and supporting the transition to cleaner energy sources. 3. Infrastructure reuse from decommissioned facilities. The focus on reusing retired infrastructure, particularly from coal facilities, to support new energy demands is another surprising element. Typically, decommissioned facilities represent a loss of energy production capacity. However, the DOE's strategy to repurpose this infrastructure for data centers and other energy-intensive industries suggests a creative approach to managing energy transition challenges. This not only allows for cost reductions but also leverages existing investments, challenging the notion that new infrastructure must always be built from scratch to meet rising demands. 4. Innovative rate structures supporting expansion. The engagement of stakeholders to develop innovative rate structures that accommodate both expansion and affordability is a counterintuitive approach. Generally, rising demand leads to increased costs for consumers. However, the proactive efforts to design favorable rate structures could help maintain or even reduce costs for end users despite the anticipated surge in energy consumption. This approach reveals a nuanced understanding of market dynamics where collaboration and innovation can lead to cost savings rather than the expected price increases. 5. Electrification as a cost-reducing strategy. In sectors like transportation and manufacturing, the electrification trend is often viewed as an expensive transition. However, the anticipated energy cost reductions suggest that increased electrification could lead to overall cost savings. The integration of electric vehicles (EVs) and advanced manufacturing processes may initially appear costly, but the long-term benefits, including reduced operational costs and enhanced efficiency, challenge the assumption that electrification will inherently lead to higher expenses. 6. The role of advanced technologies in cost management. The expected commercialization of next-generation energy technologies such as advanced nuclear and geothermal energy presents an intriguing counterpoint to the belief that energy cost reductions must come from more conventional sources. The integration of these advanced technologies into the energy mix could yield significant savings and efficiency improvements, suggesting that innovation rather than traditional energy sources is key to achieving lower costs.
Conclusion.
The anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 defies conventional wisdom in various ways. The simultaneous rise in consumption, potential transformation of data centers into grid assets, and innovative strategies for infrastructure reuse and rate restructuring highlight a forward-thinking approach to energy management. This evolving landscape challenges long-held assumptions about energy consumption and costs, emphasizing the power of innovation and strategic planning in achieving sustainability and affordability in an increasingly electrified economy. The report on the anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 contains several crucial elements that may be overlooked by many readers. These elements, while not the central focus of the summary, provide significant insights into the broader implications of energy transition strategies and technological advancements. Below are some of the key overlooked aspects along with their significance.
1. On-site power generation and storage.
Significance. The mention of on-site power generation and storage technologies, especially concerning data centers,
is critical. This strategy can transform data centers from being mere consumers of electricity into active participants in the energy grid.
By enabling data centers to generate and store their own energy, they can reduce their reliance on the grid during peak demand times, thereby mitigating the stress on the overall energy system. This shift could help stabilize energy prices, enhance grid resilience, and promote the integration of renewable energy sources.
2. Utilization of retired infrastructure.
Significance. The report highlights the potential of repurposing retired coal facilities for new energy needs. This is significant for several reasons. It represents a sustainable approach to infrastructure use, reduces waste, and aids in the transition toward cleaner energy sources.
Moreover, utilizing existing structures can accelerate the deployment of new technologies while minimizing capital expenditures.
This strategy could also have social implications, as it may help in transitioning workforce skills from fossil fuel industries to renewable energy sectors.
3. Innovative rate structures. Significance. The engagement of stakeholders in creating innovative rate structures is an essential yet often ignored aspect.
These rate structures can play a pivotal role in ensuring that energy remains affordable while supporting the expansion of energy-intensive industries. By aligning the interests of consumers, utilities, and investors, such structures can incentivize energy efficiency and the adoption of advanced technologies, ultimately leading to a more sustainable energy economy. 4. Advanced technologies and market adaptation. Significance. The report discusses the commercialization of advanced technologies such as geothermal energy, advanced nuclear, and long-duration energy storage. The significance of this lies in the potential to diversify the energy mix, reduce carbon footprints, and enhance energy security. As industries become more electrified, adopting these technologies can help ensure a stable and reliable energy supply,
which is critical for economic growth and environmental sustainability.
5. Impact on employment and skills development. Significance. Although not explicitly mentioned, the transition to lower energy costs and advanced technologies will inevitably affect the job market. Industries such as manufacturing and agriculture may undergo significant transformations, requiring a workforce skilled in new technologies. This presents both challenges and opportunities. the need for retraining and upskilling existing workers while creating new jobs in emerging sectors.
Addressing these workforce needs proactively will be vital for maintaining economic stability and ensuring that the benefits of energy transitions are widely shared. 6. The role of artificial intelligence (AI). Significance. The report notes the surge in AI applications as a driving factor behind increased energy consumption in data centers. This is significant because it underscores the need for sustainable AI practices. As AI continues to permeate various industries, its energy demands could exacerbate existing challenges in energy consumption. Developing AI technologies that prioritize energy efficiency could not only mitigate costs but also align technological growth with sustainability goals. 7. Long-term economic implications. Significance. The projected cost reductions in energy could have far-reaching economic implications. For instance, lower energy costs can enhance the competitiveness of U.S. manufacturing, potentially reshoring jobs and manufacturing capabilities that had previously been outsourced. This could lead to greater economic resilience and reduced dependence on foreign energy sources. Moreover, in agriculture, reduced operational costs can lead to lower food prices, benefiting consumers and potentially increasing food security. 8. Interconnection of industries. Significance. The interconnected nature of the four industries mentioned in the report, transportation, manufacturing, agriculture, and data centers, should not be overlooked. Changes in one sector can ripple across others, influencing energy demand, supply chains, and operational efficiencies. For example, advancements in electric vehicles (EVs) can lead to increased demand for energy in data centers for charging infrastructure, while also encouraging innovations in manufacturing processes. Understanding these interconnections is crucial for stakeholders to develop comprehensive strategies that maximize benefits across the economy. Conclusion. The anticipated 50% reduction in energy costs by 2028 is not merely a statistic. It reflects a complex interplay of technological innovation, policy development, and economic implications across multiple sectors. The overlooked aspects of on-site generation, repurposing infrastructure, innovative rate structures, advanced technologies, workforce development, AI impact, long-term economic implications, and inter-industry connections provide a richer understanding of the potential transformations ahead. Recognizing and addressing these elements will be essential for stakeholders aiming to navigate the evolving energy landscape effectively and sustainably. 1. Projected energy consumption trends. The anticipated surge in energy consumption, particularly in data centers, is a crucial aspect of this analysis. The U.S. Department of Energy (DOE) reports an increase from 58 terawatt-hours (TWh) in 2014 to 176 TWh in 2023, with projections suggesting consumption could reach between 325 TWh and 580 TWh by 2028. This trend highlights the rapid expansion of industries that rely heavily on electricity, especially with the rise of artificial intelligence (AI) applications and domestic manufacturing. Understanding these trends is vital for policymakers and stakeholders to prepare for and manage the increasing energy demands effectively. 2. Innovative strategies for energy cost reduction. The report outlines key strategies and innovations being developed by the DOE to address rising energy demands and facilitate a 50% reduction in energy costs across the targeted industries. These include on-site power generation and storage solutions, reusing retired infrastructure from coal facilities, and creating innovative rate structures to ensure affordability while supporting industry growth. A thorough examination of these strategies can provide insights into how effectively they may combat rising costs and enhance energy efficiency. 3. Sector-specific impacts. The anticipated reduction in energy costs is expected to have profound implications across the four key industries: transportation, manufacturing, agriculture, and data centers. Each sector presents unique challenges and opportunities for energy efficiency improvements and cost savings. For instance, in transportation, advancements in electric vehicle technology can lower energy costs, while in manufacturing, Electrification can enhance competitiveness.
An in-depth analysis of how each sector can adapt to and benefit from these changes is essential for understanding the broader economic impact. For future outlook and economic implications, the timeline from 2014 to 2028 illustrates a significant shift in energy consumption patterns and the corresponding need for innovative solutions. The DOE's proactive approach and investment in clean energy technologies are crucial for ensuring economic growth and energy affordability in an electrified economy. Analyzing the potential economic implications of these changes, including job creation, investment opportunities, and the overall impact on energy markets, can provide a comprehensive understanding of the future landscape of the U.S. energy sector. 1. The Industrial Revolution and its impact on energy consumption. 18th to 19th century. The Industrial Revolution, which began in the late 18th century, significantly transformed energy consumption patterns across various industries,
including manufacturing and transportation.
The shift from hand production methods to machines powered by steam engines and later electricity led to unprecedented increases in productivity and efficiency. This transformative period saw the introduction of coal as a primary energy source, leading to a dramatic reduction in production costs and a surge in economic activity. By the late 19th century, innovations such as the electric motor began to replace steam engines, further enhancing energy efficiency in manufacturing processes. 2. The oil crisis of the 1970s. The oil crises of the 1970s had a profound impact on energy costs and consumption in the United States and worldwide. Triggered by geopolitical conflicts and OPEC's oil embargo, the crises led to skyrocketing energy prices and prompted governments and industries to rethink their energy strategies.
In response,
there was a significant push for energy conservation and the development of alternative energy sources. This period saw advancements in fuel efficiency for vehicles, increased interest in renewable energy, and the implementation of energy-saving technologies across various sectors, including transportation and manufacturing.
The long-term effects of these changes influenced energy policies and practices for decades to come.
3. The Green Revolution in agriculture. 1940s to 1960s. The Green Revolution refers to a series of research, development, and technology transfer initiatives that occurred between the 1940s and the 1960s, resulting in significant increases in agricultural production worldwide.
Innovations such as high-yielding varieties of crops, chemical fertilizers,
and improved irrigation techniques drastically reduced the cost of food production and increased efficiency in the agricultural sector. These advancements not only enhanced food security but also led to a reduction in energy costs associated with farming practices. The adoption of energy-efficient technologies in agriculture continues to evolve, contributing to sustainability and cost-effectiveness in food production today. Future outlook: anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028. The anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 represents a significant shift in how industries approach energy consumption and efficiency.
This projection is rooted in advancements in technology, innovative strategies,
and a growing commitment to sustainability. Below are key predictions and insights into how these changes are likely to unfold across the four sectors.
1. Transportation sector innovations.
The transportation industry is poised for a transformation driven by electric vehicle (EV) adoption and infrastructure improvements.
By 2028, it is predicted that
widespread EV adoption, the number of electric vehicles on the road, is expected to increase significantly, fueled by advancements in battery technology and government incentives. This shift will lead to lower operational costs for transportation companies, ultimately contributing to a reduction in energy expenditures. Enhanced charging infrastructure, investments in charging stations and smart grids will reduce downtime and optimize energy use during off-peak hours, leading to more efficient energy consumption. Alternative fuels: the incorporation of biofuels and hydrogen fuel cells will diversify energy sources.
allowing for reduced reliance on traditional fossil fuels and lowering overall costs. 2. Manufacturing sector advancements. Manufacturing is likely to experience a renaissance in energy efficiency through increased electrification. Many plants will transition from fossil fuels to electric power sources, particularly in energy-intensive processes. This shift is expected to yield significant savings as electricity becomes cheaper and more reliable. Smart manufacturing technologies. The adoption of IoT devices and AI-driven analytics will optimize production processes, resulting in energy efficiency gains. Predictive maintenance will reduce downtime and energy waste, further driving down costs. Sustainable practices. A growing emphasis on sustainability will lead manufacturers to adopt renewable energy sources such as solar and wind, which will stabilize energy costs in the long term. 3. Agriculture sector transformation. In the agriculture sector, the focus on energy efficiency will lead to several promising developments. Precision agriculture, technologies such as drone sensors and data analytics will enable farmers to optimize resource use, including energy, water, and fertilizers. This precision will lower energy costs significantly. Renewable energy solutions. The adoption of solar panels and biogas systems will enable farms to generate their own energy, reducing reliance on external sources and lowering operating costs. Energy-efficient equipment. The transition to energy-efficient machinery and irrigation systems will further decrease energy consumption, leading to substantial cost savings for farmers. 4. Data centers and energy management. Data centers are at the forefront of the energy transformation due to their rapidly increasing demand. Innovative cooling solutions. New cooling technologies will improve energy efficiency in data centers, which currently consume vast amounts of electricity for cooling. Techniques like liquid cooling and advanced airflow management will become standard. On-site energy generation. Many data centers will invest in on-site energy generation and storage solutions such as solar panels and battery storage, making them less dependent on the grid and more resilient to price fluctuations. Smart grid integration. Data centers will increasingly act as grid assets by participating in demand response programs, allowing them to sell energy back to the grid during peak demand, thus bolstering their economic viability. Conclusion. The anticipated 50% reduction in energy costs across transportation, manufacturing, agriculture, and data centers by 2028 is not merely a hopeful prediction but a likely outcome of ongoing technological advancements, regulatory support, and a shift towards sustainable practices. Each sector will contribute to this collective achievement by leveraging innovations that enhance energy efficiency, reduce costs, and promote environmental sustainability. As industries embrace these changes, the impact will not only be felt in reduced operational costs but also in improved competitiveness and resilience in a rapidly evolving energy landscape. By 2028, organizations that adapt to these trends will be better positioned to thrive in an increasingly electrified and environmentally conscious economy.